find what? An expression for the relationship between molar heat capacity at constant what? Pressure and molar heat capacity at constant what? Volume. All right. Now, this relationship is also known as Meyer's equation. It's also known as what? So what they ask you to prove then is Cp minus Cv equals to what? R. Okay, so like I said, this equation is known as what? Meyer's equation. So in some cases, they'll just tell you derive Meyer's equation. Are you getting me? Now, your molar heat capacity at constant pressure is your what? P. While molar heat capacity at constant volume is what? Is V. Are you following? Your arrow there represents your ideal gas constant. Okay, that's your gas equation, the ideal gas constant. So this time around, when you are proving your Meyer's equation, what you normally use, okay, you use first law of what? Thermodynamics. You make use of what? First law of what? Thermodynamics. Now, this is how to go about the solution. And first law of thermodynamics, we have dq equals to du plus dw. Our dq represents change in quantity of heat transfer. Change in what? Quantity of heat transfer. The y du represent change in internal energy of the system. The y dw represent what? Change in work done by the system. Are you following? All right. Now, our dq, what you do, you call this very one equation what? Equation 1. So our dq is stating as Cp dt. So you call this equation what? 2. The y du is stating as Cv dt. You call this equation what? 3. So y dw is stating as P dv. So you call this equation what? 4. So what you do, you substitute equation 2, 3, and 4 into what? Equation 1. So you put equation 2, 3, and 4 into what? Equation what? 1. Now this time around, what's our equation 1? Is dq equals to du plus dw. You already know what's the dq now, right? Our dq is written as what? Cp dt. The equals to what's du? Cv dt. And what's the w? That p the what? Dv. So you can call this equation what? 5. Now this time around, if you observe, this is what they ask you to prove. In this very equation, there's already Cp and there's already what? Cv. But is there anything like R here? Is there anything like arrow? No, since there's nothing like arrow, we have to introduce our what? Arrow. How do you introduce that arrow? You recall from your ideal gas equation. Are you following? You recall from what? Ideal gas equation. So if you recall from ideal gas equation. Okay. Now from ideal gas, don't forget we have PV equals to N RT. PV is equals to what? NRT. You can remember this equation, right? So our PV is equals to NRT, where P represents pressure, volume, then number of moles. Then you have your what? Ideal gas constant and your what? Temperature. Now, this time around, for monoatomic gas, for monoatomic gas, our N is equals to what? 1. Are you following? For monoatomic gas, N is equals to what? 1. Since our N is equals to 1, if we substitute 1 into this place, so we are going to add PV, then equals to, that is 1 times RT. Is it not? And then you have it as well, PV equals to what? RT. What you do, you carry out what is called what? Integration. So by next semester, I'll be doing calculus. So what you do here, hello, you integrate your P in respect to V and integrate your V in respect to P. And in this way, integrate your what? Arrow in respect to what? T. And in doing so, Yeah, whenever you integrate the respect to the, we are going to add p dv plus, if you are not integrating this in respect to the, you have it as v dp. And in this way, you are only integrating r in respect to what? T. Here become what? Arrow d what? Arrow d t. Suppose you are integrating the respect to, you have what? D, t d what? The arrow. Are you following? So this time around, at constant pressure, at constant pressure, that your isobaric process. At constant pressure, our P is equals to what? Is equals to 0. Are you following? Now that is our dp. This time around, anywhere you see dp, you substitute what? You substitute which value? 0. So from this place, we have it as p dv, then plus v times what? What's the p? The p is what? 0. Then equals to arrow the what? Arrow the t. Now that you have that, so we have it as p dv, then plus v times 0 is what? You have 0 equals to arrow dt. So this time around, what you do, p dv plus 0, what do you have? We have p dv equals to arrow dt. You can call this equation what? 6. So what you do here, you substitute your equation 6 into equation 5. You substitute equation 6 into what? Equation 5. That means anywhere you find p dv here, you represent it with what? Arrow dt. Can see here from your, from this way, you were told that your p dv is equal to, that is the same thing as what? Arrow dt. Are you following? So this time around, what do you put? Equation 6 into what? Into 5. And what's our equation 5? We have cp dt equals to cv dt, then plus what? Plus p dv, right? Now this is our equation what? 5, is it not? So this time around, anywhere we find our p dv, we represent it with what? Arrow dt. Are you following? So this time I will have it as p cp dt equals to cv dt plus what's p dv? Arrow the what? Dt. Now what can you observe from here? You observe that dt is common, right? Dt is common, is it not? So what you do, you divide through by what? By dt. If you don't want to divide through by dt, you can factor out what? Dt. Are you getting me? From this side. Now this time around, you divide through. Divide through by what? By dt. So from this base, it becomes cp dt all over what? Dt. Are you following? Then equals to cv dt all over what? Dt. Then plus arrow dt all over what? Dt. So this time around, this can cancel out this, then this can cancel out this, and this can cancel out this. Are you following? So what are you now going to have here? cp equals to cv plus arrow. Now to make this one to stand alone, this one will move over to this other side, right? So you have it as cp minus cv equals to arrow. So this is your Meyer's what? Equation. All right, you can copy that.